If you can get the mic working. Hello, everyone, and welcome to Ingrid Capacity's panel on the topic, what can the energy sector learn from tech leaders? Our energy systems face an immense task of leading the green transition, enabling industry electrification, and ensuring Sweden's competitiveness through secure and affordable energy. This requires innovation, and with that also a keen adoption of new technologies and digitalization. Large energy companies that have been around for a while and have a lot of knowledge need to focus on maintaining their systems and should not alone be responsible for driving this transformation. However, young and bold startups with another ability of moving quickly and adopting technologies faster lack the full knowledge and scale to do it by themselves. That's why we need to talk to each other, we need to collaborate, and we need to learn from one another. And that's exactly what this panel will be about. Ingrid Capacity, who's hosting this panel today, is an energy tech company specialized in developing, operating, maintaining and owning, and optimizing flexible assets. We started 2 years ago we're based in Stockholm, in Sweden, and we're building assets all across the energy markets, SE3 and 4. And according to Ny Teknik, we are the largest BESS provider in Sweden, and we are now expanding to the rest of Europe as well. My name is Clara Humla, and I joined Ingrid Capacity about a year ago as their first data engineer in the team, which is now the largest team at Ingrid Capacity, the tech team. I have previous experience from enabling AI through high-quality data in a variety of sectors, such as autonomous driving at Volvo Cars and open banking at Tink. And I'm here today to lead you through this panel. And I will start off by just pointing out that we have an emergency exit right where you came in, run in that direction, or go left after the entrance. So then I can start with introducing our esteemed panelists. So we have Niklas Sigholm, who's founded the company Sigholm in 2010 and has ever since worked with both strategical and operative questions regarding the energy sector. He has also developed cloud solutions for energy sector, and he is a thought leader within energy, also due to the fact that he is the voice behind Energistrategipodden.
Thank you.
We have Linda Maria Wadman, who is Chief Commercial Officer at Plexigrid, meaning that she is responsible for marketing and sales and business development globally. She has over 15 years of experience within critical control systems for the grid and has also had a variety of management positions within the energy industry. And we have our own Andreas Langholtz, who is Head of Tech Strategy at Ingrid Capacity. He recently joined us from his time at McKinsey's AI division, Quantum Black, where he helped different industries and companies adopt AI. And we have, last but not least, Thomas Olsson, who is founding engineer at Einride, as he wrote the first lines of code in their tech stack. And he has since then been involved in different areas within the company and is now the Senior Vice President of Autonomous Driving Systems. Welcome.
Thank you.
Thank you.
Thank you.
We will start with a general question to all of you around the table, and you get to answer one by one. I believe that you all agree when I say that digitalization is important for the green transition, but how far would you say that the energy sector has reached in this matter? Niklas.
Well, it certainly depends on which part of the energy system that we're looking at. Just easily describing it as some sort of raw materials to some sort of supply and power production to the distribution and the end consumption of it. And the different parts have reached they need to take different pathways, and they come different paths, not as far. I would say that right now it's the consumption part. It's really this end customer interface that it has reached the furthest. And I would say as the production part is perhaps starting, the grid is lagging behind. We've had a long discussion about this. So if you divide the energy system in those 4 categories, I would say that the furthest is definitely the end consumption part.
Linda Maria.
Yeah, you put the words in my mouth, Niklas. But no, I started thinking about 15 years ago when in one of my previous employers, we already had what we call the smart grid department, and we were doing pilots, moving laundry machines, washing at night, and presenting CO2 emissions to customers to get them to change their behavior. And it feels sort of like we are still talking about almost the same things today. So not much changed. And in the same time frame, we got Spotify, we got cloud computing, we got EVs and everything. But to be a bit more positive, I still think that here in the Nordics we come quite far when it comes to digitization. We have smart meters roll out. EU had a target to roll out smart meters 2020, and how many countries reach that target? There are many behind still. So there are some lights in the tunnel.
Andreas.
I think similar to what Niklas said, that it depends a lot on where you look, and I think we are very biased at this table because we do data every day and we read about AI, but if you look at the big drivers of the energy system, it is still very large old companies, and there is a long way to go. So sort of 3 out of 10 on a scale from farming to Amazon and Google. And also on the regulatory side and on the sharing side, I think we're going to discuss this, a great many industries we can look to, for example, share data on grid load, have good collaboration without monopolizing the industry, that really benefits sort of the entirety of the system.
Thomas.
I'm impressed you gave a number, 3 out of 10. It's pretty bold.
I used to be a consultant.
No, but I think it depends on where you look. I think that's key here. We're live in both America, in the Middle East, and in Europe, across different markets and countries. It's vastly different. I think we in the Nordics are a bit better off than most places. But of course, looking at United States, is a super diverse place across different states. But looking at our own industry, movement of freight, it's still very much a pen and paper industry. It's still the same thing as it used to be, but for us, electrification has been an opportunity to change that. But that also means we work with very, very diverse customers, where some have almost nothing, and others have very advanced systems and algorithms, and even thousands of engineers working on building those logistic systems. So that means we need to build functionality that caters to everybody. But then integrating with utilities, as we're building some of the largest charging infrastructure out there, also very different. Some have serious simulation tools and can, we ask a question about, can we do this? And they can tell us quite promptly, yes or no. And then you have other ones that's like, here's the queue, wait in line. And it doesn't really matter what type of task you have. So it's vastly different.
Thank you. So let's explore a little bit the potential of AI and data-related technology in the energy sector. As a matter of fact, the electricity grid is only used at its full capacity 2% of the year. Linda Maria, could you share the potential that you've seen in using AI-related technologies in optimizing the grid?
I would say that AI for grid applications is still in its infancy in many ways. But it's absolutely a big buzz, and it will be critical to achieve running a more efficient energy system. Some things that AI is already good at right now, I mean, the types of AI that we have commercially available, like machine learning, it's really good at helping us running applications with bad data. So it can help clean data, fill data gaps, find outliers, that type of applications. And it can also help forecasting behavior of customers pretty well. So that's mature. But then when it comes to the more autonomous operations or automation of the grid, I would say that we are not there. We don't need more complex AI tools. I mean, comparing to autonomous driving, I would say you are really aiming high there. And we would need to have the same type of technology in the grids, because what happens is that you will get to these unexpected situations that you cannot train for in the same way as you train the machine learning algorithm. So, and quite high risky situations. You don't want to have a blackout. So how can you manage that situation with an autonomous and automated way?
Thomas, how has AI enabled or acted as an enabler in your field?
I think for us in particular, it's basically all over the stack. I mean, for electrification, the most important thing that we've had for some time is energy prediction modeling, because that's just the complexity goes through the roof when you have different vehicles for different manufacturers with different drivetrains, with different batteries, with different chemistries, and the list can just go on forever. And that's where we can use AI to take that complexity and make it into something understandable. So our fleet optimizer can then distribute the vehicles with the right type of properties for the right type of task across the system. And that's where we can start to get consistent loads on our charging infrastructure and start delivering that data as well to our partners around the world in terms of utilities. So, of course, the whole AI end inside of vehicles, it's in the cloud, it's using the same infrastructure, but it's vastly different. But we do share a lot of data learnings and data pipelines and whatnot. And it's sort of penetrating just more and more pieces of the technology stack.
Thanks. So there seems to be quite immense potential of AI in the energy sector as well. But the real question is to actually acquire it and how to navigate that path. And the energy sector isn't the first to undergo a similar transition. So there is probably plenty we can learn from other industries. Andreas, what have you learned during your time at McKinsey when you helped different industries to adopt AI?
I think we've seen also with the rise of AI lately how important having your sort of foundation and baseline in order. We all know the sort of explosion of ChatGPT and so forth. And I think what we really saw there is that the ones who have a good cloud setup, who has invested in having their data in place, who knows where their documents are, they're the ones who are able to do automatically generated contracts and tenders and bidding and really speed up these heavy processes. And this is where I believe a lot of the real value lies also for utilities. I would say in terms of other industries, I think there are a few, we tend to see the energy sector as super regulated, very difficult, very engineering, and we're not just an app or something you can build. But I think something like pharmaceuticals are miles in front of us. They have the mindset, right? That's their bread and butter of something that might pay off 20 years down the line. But really do heavy investment early on and bet on big things with good business cases, and also ingrain that in your full sort of corporate process. That it's not just the tech team, it's also the financing, it is the operations, it is sort of everything in your company that supports the adoption of technology.
Niklas, what does it take for an energy company to go from on-prem solutions to cloud?
Well, first of all, just to connect to what everybody said before, I think understanding the economical potential of doing this, because it might seem hard to understand, but we had a podcast about this, and there are two different things about this. The one thing is the cost to society. I mean, I've seen, since we spoke about this, I've seen other figures from big utility companies of just how big the impact is to raise the efficiency in the grid just a few percent. I mean, it's basically hundreds of billions of Swedish crowns we're talking about up until 2045. So it's massive amounts of money that we could save doing this in the utility sector alone. So that's the one thing. The other thing is this is what's driving competition, right? So the complexity that you are talking about, it's on its way. It's already here in the energy sector. We get a lot more assets in the grid with different capabilities. We get batteries, we get solar, we get charging points. I mean, it's really exploding, right? So how to handle this? It really comes down to what you're saying, because it's reducing the complexity to a manageable piece of information that you can take decisions upon. But in regards to your question, then I used to compare it to draining your house, right? Because you've got all these legacy systems, and transforming your legacy system to a sorted cloud-based solution it's really costly. It's time-consuming. It destroys your garden, like draining your house. It's horrible, right? All your flowers are ruined. and then you can't immediately see the benefit in your house. But you know it's with a long time view, it's really important for the house to be safe and healthy, right? So this is the same thing. You need a clear strategic mind view of how this is going to change the foundation of how you compete in the market. And if you understand that, then you can start allocating resources in the right way to this type of topic. But then you've got different layers of competencies in the different organizations, right? And really, it's important to link the computation from the OT systems all the way up to the management level. And I think that is what the energy companies now really need to do. That's one thing to say. But
can I just add a comment to that? I mean, if you compare to buying a hardware, you buy a box of something that you define, you specify, I want it to work like this, I want it to sit there for 20 years or 50 years, it's not going to change. But when you buy an AI solution or a software, you need to have a mindset that I buy this because it will evolve, it will change, and that's the purpose of the thing. I don't buy this because this is what I want, that I can even foresee everything now.
And that's what we used to, right?
Yeah, exactly.
So Andreas, you actually contributed to a publication by McKinsey with the title, Cloud's $1 trillion prize is up for grabs. That's immense numbers. Can you share a little bit the reason behind these numbers?
Yeah, I mean, should always be suspicious about a consultant saying they found $1 trillion, but I think it's very similar to what Niklas is saying, right? That what we tried with that article still very much stand is to create a unified framework for what is it actually worth to have a modern tech stack. And very often as a decision maker, if you are CEO or something in a big old organization, what you see is sort of IT saying, hey, we need this because of security, and R&D says, I need more data. But taking the holistic view and saying the business case for all of this is all the operations. It is all the current technologies, and then it's also preparing you for the future, right? It's even your ticket to be relevant in the long term that you start investing now. And to my former point, that's what we saw. This was in 21, and then ChatGPT happened in 22. And it was almost exactly that sequence.
So talking a little bit about regulation and policies, and I'm talking to you now, Thomas, because when you entered the market, there must surely have been plenty of regulation and policies that you've had to deal with. How can these regulations and frameworks be adapted to help the adoption of technologies such as AI rather than block?
So it's there's many parts to that question, but we've obviously worked for a long time now. We deployed the first time on public roads in 2019. I remember when we started speaking with regulators, and they were saying you're going to need seatbelts in your vehicles, you're going to need rear view mirrors, and we're saying there's nobody that's going to look at those. Nobody's going to use the seatbelts.
Because you do autonomous trucks.
Exactly, without a cabin,
yes.
So there's really nowhere to put those things. But that was just the way the regulation was formed. But I think over time we also became better at understanding the circumstances in which the regulators are, and they're trying to look at existing regulation to sort of lean upon. So if you do that, if you manage to help them lean on existing regulation, you make their job a lot easier. And then it's the other tricky end of politicians writing new laws. They have great intentions typically. They write something, they think they solved the problem, and then interpretation comes, and they say, well, actually, maybe you didn't. And then you get this back and forth where, stuff just doesn't happen. But that's where there's obviously other great markets in the world where you can be engaged. So we're right now live in Tennessee and Kentucky in the United States, where we're driving every day, autonomously shipping goods. And we just signed one of the largest deals, the largest deal for autonomous heavy freight in Dubai, actually. So I should say that there's a lot of people on the regulatory end that really wants this to happen, and politicians really want it to happen. It's just that the communication breaks down sometimes. And that's something you invest in, get better on, and again, try to really understand the view of the regulator to help them do their job.
And the rest of you, what would you wish from your regulations and policy frameworks?
you want to start?
Yeah, well, I would say that to drive, I think you mentioned the word competitive, or to be competitive or win the business. If you are working in the grid segment, I mean, you have a different business model. Your business model is so complex that even people in the industry don't understand it. And how do you make money as a grid operator? You have to read a lot of regulation to really understand what drives it. And at the same time, you're also running this mission critical service to society. So naturally, regulation and instructions becomes very important. And I think that can be really a challenge when you try to be innovative, because the regulator is setting the business targets, and the business targets are not about being competitive, being best, having the happiest customers or having the best services necessarily. So I think having a regulation that drive to different outcomes, such as customer satisfaction or efficiency or cost, could help a lot, also driving these innovative initiatives.
I think that is happening. I really think the governing agency in Sweden has understood this. What I can read from their communication right now, I think they're doing a lot better. And I also think that the regulation that is coming from the EU right now is in a really positive way, also underlining this and giving the grid and producers an assignment to know how to handle if all of a sudden I got Ingrid Capacity in my grid and you want to cooperate or you want to be able to trade with me. I need to be able, according to regulation, to do that with you. I need a handshake. And then when you say, you know what, my handshake is very autonomous. Is your handshake autonomous? And I go like, no, then we can't trade. And you're not applying with the current regulation. That will create lots of problems. I really think that this is not as much about regulation right now, because the new net codes and everything is on its way. Now it's about how we really implement them in the system. So that's what I think. But of course, sandboxing and doing stuff like that is really good as well.
And maybe also sometimes, at least in autonomous vehicles, one of the big issues is you have a software that is taking very life and death decisions on what to do. And you have a software that's updating all the time because it needs to, otherwise it's not safe. And I think that is something that is really hard sometimes for regulators who's used to having the black box you mentioned, that they can look at and they can detail, they can test it, certify it, while the software is just another story. And then you got to ask regulators start becoming data-driven, where you can show that things are working, that you have signs, you have control systems, a million different types of data pieces that can prove that you're actually safe and you have tested the system regularly, like in a great way. But that's a big shift in mindset.
I think here we should also really see politicians and regulatory landscape not just as sort of holding back, but as actually creating and accelerating market. Like to my former pharma analogy, there you have a lot of sharing, because it's believed that if everyone gets good access to clinical trials and have, that is actually for the sort of greater benefit of the population, right? And I think one example we've seen and we just discussed is subsidies. Like the IRA in the US is so easy to understand, and it's so easy to figure out this is what is subsidized, this is how it works. Really taking that to heart, right, and say we can promote, we can create. Good example, the Nordic integrated power system, the balancing market. We can actually create these structures politically that solves the problem that sort of free market capitalism can't.
So let's talk a little bit about the inherent complexity of the energy systems and the complexity that we add when we add new technologies such as AI and data-related products. Because when you add these technologies, you're not only required to have a deep technological knowledge, you also need to handle the timeline mismatch between these capex-heavy projects requiring long-term planning versus the fast-evolving AI projects. Thomas, how does one handle this properly?
Like the hardware-software part is hard on so many levels. I typically say that engineers are either hardware or software people, because you typically have a mindset where you try to fix everything with the same nail. Sometimes you just try to fix it with hardware, and software engineers typically want to fix it with software. But I think where everything is moving is that you can upgrade things over time, that software is moving into the bolts almost of vehicles and of components. And I think that's the inevitable way, because if we're going to make things more efficient, we're going to have to make sure we can continue to update things to make sure that we don't get APIs that are incompatible, that it's a living, breathing product that you can update. So that's one piece of the CapEx game. Then for us, figuring out models where you can enable new technology that is not well known, not well modeled in terms of economics, and use that to get loans to finance that hardware. That's a tricky bit in itself, but typically with any sort of big change in technology, finding a model where you can utilize loan capital to finance that transition, it's critical, because otherwise it just, well, you're going to keep it on your balance sheet, it's just impossible. That's a few things comes to mind.
So it's all about adapting to changes quickly, which sounds a lot like the agile development framework that many software development companies go by. Are there parts from this agile development where you work in iterations and try to provide software quickly that you can directly apply on the energy sector, and how?
Well, I was thinking, it's funny that you said that about I always talk about either you are a product or system person. And if you think about it that way and introduce the agile aspect, if you are a system person, then you really want you want the software and the hardware to play together, because you understand it's a system, where the product person is more looking at the black box. And then you can really, the software agility can really help that integration process with the hardware, because it's kind of in the nature supposed to evolve. And also it's naturally integrated with a lot of other stakeholders and a lot of other systems. So it has to be able to be agile. So you need to have that. I think that's the key, to have like the system mindset to everything.
Sorry, Nick.
I just think the partnerships are critical here, because in the energy sector you mentioned before the security issue. You also have the safety issue. I mean, both of those two are forces that really dampens your willingness to take risk, right, or just try things out. And it's a very valid point from the utilities sector. So and combining this type of culture that is built upon safety with an agile, let's test, break, and iterate, is really, really hard. So I think it's really important for, on the one hand, for the power companies to join forces together, because it's a lack of competency in general in this market, and the other is to find partners to work together with, because I think that is a key to success here. I think combining those two cultures or those two work methods in the same organization is a bit doomed, to be honest, or in other cases really, really hard.
So is collaboration always the way to go?
Well, I think in Almedalen typically that's what everybody says, but to put some nuance on that, like sometimes just upgrading a system platform and change basically every bit of it over time, it can just become too much, because the complexity of handling what you have and where you're going can be too much. And that's where you need to make clean slate designs. I think for the electric truck situation, you can look at a Tesla Semi, which is built for being electric ground up. And you can look at many of the previous generation trucks out there that has been integrated to work with the same manufacturing line, like the diesel trucks and everything else. And that's where you get a lot of complexity, and handling that becomes very complicated.
Yeah, but my question to you, do you think Einar would have been established within the Volvo group? Do you think it would have been built?
No.
That's my point.
100%.
So it's really hard to combine within the legacy system something that is completely new and different.
But it has been done.
Perhaps, yes, but it's difficult.
Yes.
My point isn't that it's impossible, but it's really, really hard.
But I think actually we are seeing the dawn of sort of a new wave where it becomes not easy, but easier, that AI is moving a lot more towards a service model right now, right? That if you'd asked me 5 years ago to build a vision model, it'd be like, give me 20 engineers and 2 years to do it. Now I can just call it. And I can even play them against each other.
True.
OpenAI and Google and so forth, and I can build a little shell and switch them whenever someone is better than the other. I think this will really accelerate, also potentially inside Volvo Group.
But then again, my point is you don't have 50 OT systems to combine and 5 different control systems. I think that at least dampens the ability for them.
Sure.
And also it's about making these hard investments sometimes where it will look bad for a few years if you try to do that. Very, very costly. The stock price goes down. Is that really something you want to do? Even if you know it's the right choice. And that's the hard thing about being legacy. Got to take those bets even when it hurts. But it's so freaking hard.
So according to a DNV study performed earlier this year, the resistance to change was perceived as the most challenging barrier to digitalization within the energy sector. What's needed to cultivate such a culture?
Well, I think resistance to change maybe has something to do also with what you are trying to achieve. If you have a culture that is all the way, always forcing you to be competitive and compete and be your best. I mean, I'm thinking about the wind industry, for example, that has really built its own, it changed regulation first to exist at all, and then it's been continuously challenging itself, larger turbines, more efficient offshore platforms, digitalizing those, not so you can work from remote, but always because you had these super competitive tenders to win, and you just have to challenge yourself all the time. So creating that culture from the top where you see that there's something at stake here, something that is critical, business critical, that we have to achieve.
I think one thing that where we can really learn from tech and also on agile is, to this point, the classic story of how Microsoft and Amazon solved complexity. Microsoft threw more project leaders at a problem. Amazon said, no project leaders, no one can talk to each other anymore. And if you have a big wind turbine manufacturer and everyone is sending their sort of different specs on emails and so forth, if I make some little software update, I can break the whole thing. Whereas if I trust that everyone else has their checks, everyone else has their CI/CD and pipeline and unit test and all the classic software in place, also in engineering, also in project development, then I can make whatever change, right? And I can trust the system to sort of self-regulate. I think that's really where also agile is applicable as a concept to big engineering organizations.
It is, but it's a big investment. That's worth it, but big.
My little detour on this, I think I see Telje here is one of the companies that I've been talking to this about. I mean, there are a lot of different utilities here. I think the good thing you could do is start somewhere where you can apply it. Start within the management and see what you can do with Copilot or ChatGPT. That's a wonderful starting point. I mean, don't make it too, it's easy to make it too complex in the beginning. So start digging where you stand and try to work with these different systems and get the management team sort of understanding the potential in this. I think that's really the first thing you should start off with. That's what I would say.
And Niklas, your whole organization, Sigholm, is without managers, as far as I understand it.
Yeah.
Do you want to explain a little the thought behind that?
Yeah, but I mean, I think we're born cloud, like you guys are. So for us, the other thing we never had an internal IT system. But what we could do is that with the power of those systems, we could decentralize information. So everyone had information without emails. And all of a sudden you had all the information you needed at the top of your fingertips. And that really was something pivotal for us to create this decentralized organization, because one of the hardest things, right, is that massive amount of information that needs to be carried between different parts of the organization. And that really stifles your ability to change the organization structure as well. So that's another big part of this. Because I also think that this digitization has to come with some sort of reorganization within the companies, because it changes how the way we work, and then alas, it has to change the organization as well. And understanding how this comes together is really one of the key insights to making this happen, not except how you construct your tech stack.
I think that's called Conway's Law.
Exactly. It's called Conway's Law, but that's another story. So that's what I would say. That's how we did it, at least.
Linda Maria, with your experience from within the energy sector, would you say that this would work in any energy company?
Well, I definitely think that you cannot buy technology to solve a problem. I mean, if you think that that's that easy, then you have something to learn. And I just literally, we had a discussion just before this session with one of the grid operators here in Sweden, and they had the experience that they tried some new technology, but they weren't mature in the organization. So they thought they would learn one thing, but they learned something else about themselves, maybe. So I think that if you don't have the people and the culture, as we discussed, and the mentality to drive the change, you know, you can buy the best tech stack and it will be worthless to you, because you have to have the people driving the change and making the process change.
Do you think management less, or an organization without managers could be applicable to?
Oh, I think that's, you know, that's works. It works very, very differently in different cultures and different companies. For sure, it can be applicable somewhere and somewhere not. I think that's not like the silver bullet that will solve it now.
But I think what's important, at least for us, is that every team member feels empowered, and that they feel that they're responsible for their own time, that they spend it on the most valuable thing, and that they understand the problem they're working on. If you have some manager just, you know, telling you what to do, that's not a scalable culture. You're never going to make anything useful with that. So, that just gets back to this iterating, building out your infrastructure, building out a great product together with a great team, because those go together. It's just not possible without it.
And how do you reach such a culture where you feel empowered to make your own decisions and that you're responsible for the work that you do?
Well, I guess we're a bad example. We just started by having it. It's just the way it's been. And that's been ingrained in the DNA of the company. But for me, it's always been being critical from the very beginning. And also just telling people when they're going to start. Like, this is what you can expect here. And if you don't see that, tell me.
I agree. I think, just to add one short thing to that, I think one of the problems that power or utility companies are going to have is that many of the people, the young people now are taking, going out to the market, they are expecting this type of organization, right? They're expecting the empowerment, they're expecting the self-management, just as it is. And that's really something hard to, I think, just change because of the reasons for like safety and cybersecurity and others. So again, perhaps I'm a bit Almedalian here, but I think cooperation there is the key as well.
I just want to add that when many of us are also operating maybe in a global company with multiple cultures, and they can be challenging also because the level of hierarchy and management styles are different in different countries. So you also have to be careful and manage that keep that in mind.
That's a very good point.
But to this, I think Niklas was on something. It makes a bigger difference, I think, that a CEO sends out a summer email with AI-generated text and picture and just shows the way, right? Really, really shows. And even not saying this is what we do now and here's a cool tool, but shows excitement, right? Go experiment, try out something. Also, here's our guardrails and here's our policies. This is what you can and this is what you can't. This is IP, this is not. Feel free within the sandbox.
We're approaching the end of this panel, so I just want to summarize what we've talked about. We have stated that there is a lot of potential of new technologies such as AI and data-related products for the energy sector and for the green transition. There is still much to be done, it seems, and culture is crucial for navigating this complexity and responding to this new changing environment. But I want to ask one final question to all of you around the table, like we did in the beginning. And that is, considering that you have quite different prerequisites and circumstances than other energy companies that have been around for a while and have more legacy, what main message from everything we talked about today would you like to send to those companies and the audience in here? We can start from Thomas this time.
Whoa. No, but I think, I guess it is very important to be open for ideas and to figure out how to best empower your team members who has those great ideas. For us, working with legacy organizations, which we do a lot, our customers are typically huge global companies, for us, it's always important to find that champion within a company who dares to stick out their head and say, hey, this is actually better. If you have an organization where those people can thrive, I think you're going to be able to do a lot more.
Thank you. Andreas?
I think the sort of tools and solutions are nothing new, but the price is getting bigger and bigger. Right? So if you evaluated a cloud migration business case 2 years ago, you can probably double that now, and you should just get started.
Linda Maria?
And I will repeat what I said, that you cannot buy a tech solution that will solve your problem, but you need to have the people to do it. And I think that's been our success in our team, that people have been forced to be extremely autonomous, extremely entrepreneurial, and kind of outward facing. And so even when you're a very small team, you can do a lot with that mindset.
Niklas?
Well, I would say that recognizing that this is a strategic fundamental if you want to be a player on the power market, with that insight, please allocate resources to it, although you're not exactly certain of what benefits it might bring. That's what my message would be.
And that marks the end of this panel. Thank you so much for participating, and thank you to everyone who came here to listen.
Thank you.
Thank you.
Knuckle. Oh.